Open ISE Design Suite 14.7. If any projects are opened previously, you can close it by clicking on File, Close Project. Now click on File, New Project, and the name that I'm giving to my project is FA, Full Adder. So you need to choose the location followed by working directory here. So choose the location followed by working directory, and here top level source type will be HDL, which is nothing but hardware description language. Click on Next, Next and Finish. So a project is created by the name FA. Now here we need to type our source code. For this, right click, New Source, choose Verilog module, give the file name as FA, which is Full Adder. Click on Next, Next and Finish. So here you can type the code. So already I have typed the code in Notepad, so simply I'll go to the Notepad, I'll copy and I'll paste it there. So copy and I'm pasting it here, which is nothing but a source code. Click on Ctrl S to save. So once if you have saved, double click on Synthesize XHT. If there are any errors and warnings, you can see it in this particular panes here. This is error window, warnings and console window. So synthesis completed successfully, there are no errors. Now try to elaborate this synthesis and click on View RTL schematic, click on OK. So a module is created by the name FA, which contains 3 inputs A, B, C in and 2 outputs sum and carry. Double click to view the internals, which contains 2 XOR gates, 2 AND gates and 1 OR gate. If you want to see what is present in this XOR gate, double click on it so that you can see it clearly. So this is called as View RTL schematic. Similarly, you can double click to view the technology schematic. So here IBUF stands for input buffer, OBUF stands for output buffer, and LUT is nothing but lookup table. So once we are done with writing the source code, we need to test whether this module is working fine or not. For that, again right click on FA, click on New Source, choose Verilog text picture here, and this should be FA_TB. So this is a particular name which I am giving to my test bench. Again the location should be same. Click on Next. Here you have to select Full Adder. Why? Because you are writing the test bench for Full Adder. Click on Next and Finish. So observe here carefully. So module name, every line should end with a semicolon, and inputs are always treated as registers, outputs are treated as wires. And this concept is very important. Instantiation means you are calling the particular module which you want to test. Suppose if you are doing this in Xilinx tool, there is no need for you to make any changes here. So I'm leaving it as it is. So already that particular Full Adder, which is nothing but unit under test, is called here. So after this we need to write the test vectors. So initial begin, whenever there is a begin there will be end, and whenever there is a module there should be end module. So in Xilinx only the modification that you need to do is you need to apply different kinds of inputs under this initial, begin and end. Initially I'm giving the values of A, B, C are 0. So here always some delay of 5 nanoseconds. After 5 nanoseconds of delay, the value of A will get incremented by 1. So always delay followed by A is equal to A plus 1. Similarly, always #10 is nothing but a delay followed by B is equal to B plus 1. Again always #15 C in is equal to C in plus 1. You can write this, or else individually also you can apply the values based on your truth table. Now click on Save. If you want to see the result in console window, you need to add a compiler directive called as $monitor. So $monitor $time followed by the values. So here I want the values of A, B, C in to get changed as well as to get it displayed. So for which what I'll do is I'll give carry is equal to %B, sum is equal to %B. Next inputs are A, B, C in. A is equal to %B, B is equal to %B, and finally C in. Since you need to type these keywords as it is without any modifications. So here it should be carry, sum A, B, C in. So what is the need of this particular $monitor is, whenever there are changes in the values of A, B, C in, they will get displayed in the console window. And the $time is used to print the simulation time. Click on Save. Here choose simulation. click on your full adder underscore test bench, elaborate ISIM simulator, double click on behavioral check syntax. So no errors are there. Now again click on simulate behavioral model. So click on this icon called as zoom to full view, where you can observe the result properly. So here A, B, C are the inputs, carry and sum are nothing but the outputs. So hold on control and scroll so that properly you can see this particular waveform. Now let me check whether this code is fine or not by means of truth table. If you observe A, B, C in values are 0. So 0 plus 0 plus 0 is 0, 0. Next, similarly 1 plus 0 plus 0, sum is 1, carry is 0. The same result of the waveform you can view it in the console window here. So simply I'll try to copy this and I'll open in Notepad. So the same result you can view it here. When values of A, B, C in are 0, I'm getting sum and carry as zeros. If A is 1, B is and C in are 0, 0, I'm getting sum is 1, carry is 0. Let me check for 1, 1, 1. You can observe here, when A is equal to 1, B is equal to 1 and C in is equal to 1, I'm getting outputs as 1 and 1. So this is how we need to write the Verilog code for full adder and test by means of test bench.